Going into our last topic of Unit 4, Section 8, Measures of Central Tendency. We're going to look at some key terms, some that may be familiar to you: mean, median, mode, central tendency from stem and leaf display. Looking at this in the past, I would think it had to do with biology, but no, it's a way of showing a series of numbers. Symmetry in data sets. And let's start off with our first concept here. When we look at numbers, at a series of numbers, it's sometimes useful to see what would be the center of that number, or that series of numbers. This is the measure of central tendency. Now for our first word, mean, more properly called the arithmetic mean, is a set of data items found by adding all of the items and then dividing by the number of items that you have. In fact, we've used this before. This is called the average. Now, in the math world, we show the average using this symbol, an X with a bar on it, red X bar. Now, that would be of a sample, but if you had the whole population, the mean of that population, they use a special Greek letter, mu, which is sort of a funny shaped U, as we see here. Now, when you are collecting your data to get the mean, in the sense it's this series of items, x sub 1, x sub 2, the ellipsis, and then up to the last item, n indicating the number of items. It goes into the general formula for the mean is equal to this funny shaped E, which is the Greek symbol sigma, indicates the sum of your x values, the items in your group, divided by the number of items. So this would be the formula for the sum, the bottom, and then this is the formula for the mean. Again, these are things you want to include in your notes, some of which, again, are already in your booklet. I believe this page is. All right, let's look at our first example. 10 students in a math class were polled as to the number of siblings in their individual families, and this was the results. Now, siblings are brothers and sisters, so we had this grouping here. Find the mean number of siblings for the 10 students. So you're just going to add all of these up. Now, when you do that, the sum is 29, and there are 10 students polled, so it gives you the mean of this group is 2.9. There is another type of mean called the weighted mean. Here, your numbers of items, but we have to keep in mind now the item that you're dealing with may have a weight to it. And we'll give you the example here very shortly. This formula is a modification of the previous one, and instead of using X bar, we use W bar. So you want to be sure you're familiar with that one, where it is the sum, which is your items of data multiplied by some weighted factor, and then divided by the number of items in your set of data. Now we'll illustrate this one as well, and we see this when we think of a grade point average. This should be particularly of interest to you as students, often wondering, what is my grade point average? Here, an A grade is assigned 4 points, with 3 points assigned for a B, 2 for a C, and 1 for a D. So we're now asked to write this up in our booklet as example 2. Here's the student. We want to find the grade point average, which is a weighted mean. So take a moment, copy this chart down. For a math course, the student had a grade of A, and remember we said A's had a weighted value of 4, and we're going to multiply it by the number of credits for that course. So this must have been a very complicated math course. 5 credits. Most are 3, some are 4, but this one they're saying was 5. And then just follow through. Now, as you do the multiplication, 4 times 5 is 20. Here you're weighting the value of an A. 3 times 3 is 9. 4 times 2 is 8. And then 2 times 2 is 4. When you add up these points, you get now a sum, a sigma value, but that value is weighted, and that's 41. And you have here a total of 12 units. So 41 divided by 12 give you a grade point average of 3.42. Now, somebody knowledgeable looking at that realized this is about a solid B. If it was just a 3, then you would think of it as a B minus. And if it were 3.7, that would be like a B plus. And then a 4.0, we say, is an A average, indicating that you had all A's. Another M word, the median, which we use in the measure of central tendency, which is not so sensitive to extreme values, is the median. This measure divides a group of numbers into 2 parts. Half, which is above that point, and half, which is below it. Now, what's the procedure for finding the median? Well, first, rank the items. That is, put them from lowest to highest or highest to lowest. Then, if the number of items is odd, the median is the middle item in the list. If the number of items is even, the median is the mean of the 2 middle numbers. And I will illustrate this for you as we go on. So we're going to use, for example 3, our 10 students in the math class that were polled as to the number of siblings. Now, again, this is not ordered, but we are going to put them in order, as we see here. Now, there were 10 students, so that's an even number. So we have then 4 on this side, 4 numbers on this side, and then since this is even, we have the 2 in the middle. This would be the 5th and 6th place of our listing in an ordered way. So we take these two numbers, 2 and 3, add them together, we get a 5, and now we divide by 2. We're finding the mean of just these two numbers, which is 2.5. So after ordering them, putting them in this order, we then, since it's even, go to the middle 2 and take the average, the mean of that. So you'll notice this is the median. Our X bar for this group was 2.9. So it's somewhat close together. We have a formula to help us find the median in a frequency distribution, and write this formula in your booklet. I don't have that one here. And this has to do when they give you data and you have to do some interpretation. We say the position of the median is the number of items that you have. We add 1 and then we divide by 2. So in the sense, it's the sum of everything of their frequency. Add 1 and then divide by 2. And I'll show you an example of this. Now, this doesn't give you the value of the number you're looking for. It just shows you the position in the listing of your data. Now, for example 5, and you can sketch this, find the median for the distribution. Now, here the value is 1, the frequency is 4. So that means there are 4 1s. Here the frequency is 3 2s, 2 3s, 6 4s, 8 5s. So what would be the median of this? Well, you would have to add them together, their frequencies, and if you add all of these frequencies, you get 23. Let me just do it this way. And the formula for median for distribution was add 1 to it. So this makes this 24 then. Dividing it by 2, you get a 12. Now, this 12 is not a value. This 12 is the frequency position. So where would that be? Well, you could start adding these together. 4 plus 3 is 7. 7 plus 2 is 9. So from 9, 10, 11, 12, the 12th position then would be here, and the value would actually be a 4. So to make this clear, I've developed this little way you may have used sometime in the past for counting things. How many ones do you have? You have a frequency of 4. There are 4 ones. How many 2s? 3. How many 3s? 2. How many 4s? 6. 5s? 8 of them. So set up like this now. What would be your middle number? Well, again, we're saying it's in the 12 position. So you start counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That is the position then of your median, and that's what we worked out. So keep in mind, 12 is not the median. 12 is the position. The median value is the 4. And that's what they're illustrating. All right, let's go on. Now, the last one is the mode. The mode of a data set is the value that occurs the most often. Now, if something jumps out at you, then, that's the number that's used most. Sometimes there may be 2 big numbers, depending. If there are like 2 modes, then we use the word bi, which stands for the prefix 2, bimodal. And then there are cases where there is no obvious mode. So there would be no mode. So looking for the family that we started off with, for example 6, we had a mean of 2.9, a median of 2.5, and a mode of 3. Again, it helped us to analyze and get the central tendency of that group that we were studying. And they're summarizing this, the mode. Okay, so for example 7, they're asking us to find the mode for distribution here. This would be the easy one, because looking at frequency, we just say which one is the highest, and it's here at 8. All right, we're going to take a look now at central tendency from stem and leaf display. We can calculate this measure. The median and mode are easily identified when the leaves, that is the data to the right, are ranked in numerical order on their stem, which is the value on the left. And we can see that here in this section from our textbook, where they're actually showing you one. It says, construct a histogram and a frequency polygon. Well, here we had to put all of this data into an organized chart, as we see down below. So there are the class limits. We did a tally, as we mentioned earlier, in showing an illustration of what's there. Here there are 6, here there are 9, and so on. And we're then developing from our total data, which was 40, the percent values, and then putting them in a sort of bar graph as is displayed here. You may have one like this for your homework, so you get an idea of what it looks like. Now, here is a typical, for example, 8, a stem and leaf diagram. So we'd like you to take a moment to copy this, and then we'll go over some of the features. Now, what are we illustrating here? Well, for instance, this is the stem here, and these are the leaves portion. So 1-5 stands for 15. 1-6 stands for 16. 2-0 stands for 20. Then there's 27, 28, 29, 29. So in a stem and leaf diagram, and sometimes they can be modified, but that's what this one refers to. And if we continue, we get 36, 36, 37. Here we get a 40, 42, 42. So a way of presenting data, and this would have been your data, and then you are presenting it in a stem and leaf display. Now, if you wanted to find the mean of this, you would have to add all of these up. And then the median, again, you count the number of items that you have, and then which would be the middle value, and then looking for the mode, you would look to see what value is the greatest used. Well, looking at this, we see looks like there are 3 2s here. So your mode would be your values here. The median, since there are 20 items in this display, would be, again, we're having 20, so on this side there would be 9. This side there would be 9. And then numbers 10 and 11 in their position, you would add these two together and then divide by 2. That would be the median. And I believe they're going to show that to us here shortly. And there is the median, and there is the mode. All right, symmetry in data sets. Well, as we look at the display of the data, is there something obvious in terms of how it looks when you put it in a pattern? For instance, one of the most familiar patterns that we see in a data display is what we call the bell-shaped curve, where there's sort of a right portion and a left portion. that it's evenly distributed with a central point. Sometimes you might get the data that looks something like this. And this we would say is bisymmetrical, that there are two major points. And in other cases, there may not be any symmetry here. Now, as we think of symmetry in the human body, we think of bilateral, that the right side looks like the left side. And then in a starfish, which is not really a fish at all here, you get sort of a radial symmetry. And that's what symmetry refers to. All right, let's take a look at what they're going to show us here. Yes, again, just make some sketches of this. This would show uniform distribution. This would be binomial, that the right side is like the left. This would be the closest to that bell-shaped curve we spoke of. And this is bimodal distribution, where there's sort of like two peaks. Now we also have non-symmetric distribution, where something may be skewed to the left and skewed to the right. And here we see it. So if it's skewed to the left, you start here, and it kind of goes down toward the left. Skewed to the right, starts high on the left, and goes down to the right. So sketches of this would be appropriate. And we already had this one, bimodal, where there's sort of like two peaks. As we go into the examples now in our booklet, again, pleased to say they are all there. And in fact, I have the answer to this one as well. But again, as you look at them, what would you do? You want to find the mean. So you would add these up, and you're going to divide by what? 8. And there is your mean annual sales, the average. Now, finding the mean of a frequency distribution of salaries. Here we have the salaries of the employees. Here we have the number of employees. And let's see what we have in our booklet here. Now we have this chart, but notice, and you don't have to do all this multiplication, just see what's being done. We have 8 employees that earn $12,000. So multiplying 8 times 12,000 gives you this total. And you do this for each of the employees, and you get a grand total of 45 employees earning this much money. But notice that you have one employee over here that is $50,000, way above all the others. So this is probably the manager. And notice, because of this large salary by just one individual's, this is like 4 salaries of the lowest paid employee. We sometimes refer to this person or item as being an outlier. For instance, as a teacher, if I were to take the results of a test and try to work out the mean, the average score on that test, but I had one student that wasn't prepared, didn't come to class, and that person did terrible on the test, and let's say had a 20, and everyone else was up here in the 60s and 80s and 90s and a few hundreds, I might consider this person an outlier that I would not include in the general average. So that, again, as we looked at central tendencies, this wouldn't skew, as we were showing earlier, the data that we have. Okay, let's go on. Now, for example 3, finding the median of the list of numbers. Here, we want to put them in numerical order, and then seeing that since this is an odd number, we just go to the middle. 1, 2, 3, 4, 5, 6, 7. We would go to the fourth item, which is 13. In letter B, we'd have to put them in order. It's still odd, so again, we go to the middle. In letter C, putting them in order, but since these are 6, we have to go to the 2 in the middle, add them together, divide by 2, and then that gives us our median. So again, you'll be doing these for homework, but you want to include this as illustrations in your booklet. Now, when we are looking at things like this, here are our frequencies. What is the median? So let's illustrate one of these. So as we look at this, I've made a sort of a stem and leaf diagram of it using ticks in a sense. And 1, there is 1, 2, there are 3, and so on. Now there's a total of 20 here. So our number then would be between, we'll have 9 on this side, so it'll be the 10th and the 11th, and then 9 on this side. We have to take the 10 and 11th place value and then divide by 2. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one of the values would be a 4 here, and then we go to a 5. So to get our median, we're going to add this up and get 4 plus 5 is 9. 9 divided by 2 is 4.5. So our median is 4.5. And then using this for the mode also, it jumps right out, the highest frequency. But again, it's not 8, it is the 5. We're looking for the value that's represented here. All right, let's go on. And again, put these answers in your booklet. So we did this. Now they're using the formula here. We actually did counting. And then for value B, it would be 18. And what's in the 18th position? It would be a 6. Now remember, you have to separate frequency for the number of times an element appears as to the value of that element. And you'll be doing that in homework. Okay, now we're asked to find the modes. And as we look at this, here we see it looks like 49. Here there's an 485, 485, 487. All right, this is by modal. There are two here. And as we look at this one, there isn't any. This is non-modal. And for letter D, we just look at the greatest frequency, 8, but the value is 22. So keep that in mind. Frequency, the one most repeated is in frequency of 8, but that value is 22. Okay. Now, here is the stem and leaf display. And again, what are these numbers? Well, this number here is, remember, just add a 1 to all of these. And here we're adding a 2 to all of these, and a 3. So when you go to figure the mean of this, and this would be a daunting task, you'd have to use these real numbers. And then finding the median, how many items of data, and then which is the middle one. And then for the mode, as we look at this, does it jump out at us? Well, it looks like here, maybe, there are 3 29s. Okay, let's check it out. Write these answers up in your booklet. So when you added up all of them, and there were 40, gave you this, and this is your mean. Now, since there were 40, we had to go to item number 20 and 21, which were a 31 and a 32, add them together, divided by 2. And we did pick out the mode as 29. So there's our summary. And this winds up our last item in our Math 102 course.